Okay, let's see. We have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Then they give you these numbers. They said out of 10 to 20, make out 4-digit pin. And repetition is not allowed. Then that 4-digit pin or the arrangements must be divided by, or it must be divisible by 2. So how many arrangement can be made or created or formed? Here we have 10 to 20, right? Now how many digits do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think we'll erase the 20 and have 10. Okay, so how many arrangements can be made? Let me actually take out these spots. If the repetition of digits, they ask us to make 4-digit pin out of 10 to 20. If the repetition of digits is not allowed, and it must be divisible by 2. All right, let me erase this 20 so that we'll have 10 digits. Okay, now they told us something here. They said that they told us that the repetition of the digits is not allowed. It means that we'll do have a factorial. Remember, I hope it makes sense. We can usually calculate it using a factorial, but if the repetition of digit is allowed, you cannot use the factorial. I hope that makes sense from the previous video. Okay, now what again must we actually look at or interpret in this question? What we can actually do here is that since we know that repetition is allowed, how many arrangements can be made if we form, yes, 4-digit pin? Yes, I forgot to write that one. So how many arrangements can be made if we form 4-digit pin, then the repetition of digits is not allowed, and it must be divisible by 2. It must be divisible by 2. So we have 4 spots because they want us to form 4-digit pin. I hope it makes sense. Then how many digits do we have here? We have 10 digits, but now they told us that our arrangements must be divisible by 2. What does that mean? It means that the last digit of our pin must be an even number from those 10 digits. Even number is a number that is divisible by 2, meaning after you can actually determine the arrangements, that arrangement must be divisible by 2, or you can actually be able to divide it by 2. Then an odd number, it's a number that you cannot actually divide by 2. It will give you remainders or decimals. I hope it makes sense. So that's very, very important. So the last number must be an even number for the arrangements to be divisible by 2. Then you check out of the 10 digits that you have here. Let me count all or highlight all the even numbers that are divisible by 2. We have 10, we have 12, we have 14 as a number that is divisible by 2 or even number. We have 16 and we have 18. How many of them do we have? We have 1, 2, 3, 4 and 5. We have 5 digits, so I'm going to write 5 here because it must end with what? With an even number, so that the arrangement will be divisible by 2. I hope it makes sense. This is very, very important. Okay, then what we know is we can actually go from the beginning of the first digit, or on the first spot for the first digit. If I choose 1, remember repetition is not allowed. How many will I be left with? I'll be left with 9 digits if I'm not mistaken. I'll be left with 9 digits. Repetition is not allowed. We take it off and we don't return it back. Then let's say I choose another value, any of my choice. Let's say I choose the 10. How many digits will I be left with to form or to make a pin? 8 of them. Repetition is not allowed. I take it off and I don't return it. Then I will have 7 again if I choose that 19. So it times all these numbers. So when you times all the numbers, you're going to have what? You're going to have the number of arrangements. So that number of arrangements, let me try to use my calculator. It must be divisible by 2. I hope it makes sense. So 2520 arrangements. Then these 2520 arrangements, it must be divisible by 2. So if you divide it by 2, it must not give you remainders or any decimal. I hope it makes sense.